Sample problem 2.10. Determine the formula of sulfurous acid. Okay, so the names of these what are called oxoacids are based generally on the following idea. There's some number of hydrogens, then there's a non-metal. So let me put an X to represent the non-metal. And then there's some number of oxygen atoms. Those are the formulas for oxoacids. Now, let me show you a few examples. H3PO4, right? Here the number of hydrogens is 3, the number of oxygens is 4, and then there's a phosphorus right there. That's called an oxoacid. So some number of hydrogens could be 1, 2, or 3. So let me indicate here. The number of hydrogens is usually anywhere from 1 to 3. And the number of oxygens could be 1, 2, 3, or 4. It could, in theory, be even all the way up to 7, but you're not going to see that very often. Usually 4 is about as far as you'll see. Okay? Now, how do we make heads or tails of this? It is essentially based on the names of the polyatomic ions. So we said earlier that it's important to memorize the formulas and charges and names of the polyatomic ions. And I'm going to show you how this is related to what we're talking about here. I'm going to put a few of the polyatomic ions in. I'm going to do PO3, 3 minus, PO4, 3 minuse. Let's do, we did N, let's do ClO3 minus, ClO2 minus. Let's do SO4, SO. I'm going to higher numbers, right? So I'm sorry, let me go to higher numbers, not lower numbers. So let's make this a 2 and a 3. And then let's do for this one a 3 and a 4. Okay? So those are some of the polyatomic ions that are listed in this chapter. Now I'm going to put the names down. So when we say, oh, you should memorize the polyatomic ions, what that means is if you see this formula, NO2 minus, you should know that's called nitrite. Or if you see the word nitrite, you should know that that's NO2 with a negative charge. Okay? Now pay attention to the pattern that is emerging here. Of course, there are other ones out there as well. But these are some of them. Okay, these are some of the common ones. Do you see a pattern there? The pattern is that for any given nonmetal, let's take nitrogen for example, there could be 2 or even more, but there are for nitrogen there are 2 polyatomic ions with oxygen. There's nitrite and nitrate. The one that has more oxygens is 8. The one that has fewer oxygens is ite. Okay? So ite, fewer oxygen, 8 more oxygen. Now there is no pattern of whether it's 2, 3, or 4. So for example, with sulfite and sulfate, it's 3 and 4. With nitrate, it's 2 and 3. With chloride, it's 2 and 3, number of oxygens I'm counting. With phosphite and phosphate, it's 3 and 4. So there is no pattern of if it's 2, it's ite, and if it's 3, it's 8. You have to memorize the actual pairs. And it's useful to memorize them as pairs. Nitrite, nitrate, phosphite, phosphate, chlorite, chlorate, and sulfite, sulfate, and there are a few others as well. Okay? Now here's what happens. When we say that we have what's called an oxoacid, it's a certain number of hydrogens, the non-metal, and then a certain number of oxygens. Oxoacids are nothing more than polyatomic ions containing oxygen. So these are the polyatomic ions containing oxygen with hydrogens attached to them. The number of hydrogens is the number it takes to neutralize the electrical charge. A hydrogen ion has a charge of +1. So if you have an anion that has a charge of -1, all you need is one hydrogen to neutralize the electrical charge. It's got to have the same positive charge as you have negative charge for the anion. Let's say you have an anion that has a charge of -2. Well, if hydrogen only has a charge of +1, you need 2 hydrogen ions to neutralize the anion. And if you have a polyatomic ion with 3 negative charges, then the hydrogen ion, because it's +1, you need 3 of them to neutralize it. So you just figure out what the negative charge of the polyatomic ion is, add the number of hydrogen ions it takes to neutralize it. So let's go through them. The nitrite has a charge of -1, so you only need 1 hydrogen. That would be the acid. We're going to name it in a moment. NO3-, you only need 1. It only takes 1 hydrogen to neutralize the negative charge. But phosphite and phosphate have 3 negatives, so you need 3 hydrogens. Chlorite and chlorate, they're -1, so you only need 1 hydrogen. Sulfite and sulfate, they're -2, so you need 2 hydrogens. Now again, see how I have these as pairs? These are acids now. The polyatomic ions, you add the hydrogen ions, now you've got the acids. And because these acids have oxygen, these are called oxoacids. Okay? Now, how do we name them? The general rule is very, very simple for oxoacids. You take the polyatomic ion, and if it's an ite, the acid is called us acid. So you name the polyatomic ion and then you put us acid at the end. If the polyatomic ion ends in ate, then the acid is ic acid. Okay? Very, very simple. So let's go through all of these, and then in going through all those, we'll get the sulfurous acid. HNO2, it's nitrite. So ite is us, right? Ite is us. So nitrous. Let me erase this. Acid, right? Ite becomes us. Nitrous acid. Nitrite becomes nitrous. You're just changing the ending from ite to us acid. Nitrate, ate, becomes ic acid. So nitric acid. Phosphite, ite, becomes us acid. So phos. You might say, well, is it phosphorus acid? Actually, you keep the second syllable for phosphorus. So it's phosphorus acid. Phosphate, PO4-3, add the hydrogens, you get phosphoric acid. If you read through the ingredients of Coke or Pepsi, you will find they have phosphoric acid in them. Next one, chlorite. Well, ite becomes us acid. So this is chlorus. Let me get rid of us acid. Chlorate becomes chloric acid. Right? Last one. Now this is the one that's going to answer our question for this particular sample problem. Sulfite, sulfurous. Keep that second syllable in just like we did with phosphorus. Sulfate, sulfuric acid. Okay, so let's come back over here. Determine the formula of sulfurous acid. What you would do is you would say, oh, it ends as us acid. If it ends as us acid, that means the polyatomic ion is ite. What is the polyatomic ion that ends in ite that has sulfur in it? It's right there, sulfite. So that tells you the polyatomic ion. To make the acid, you add hydrogens to neutralize the charge. So hydrogen is +1. How many hydrogens do you need to neutralize -2? You need 2. So it's H2SO3. It's just the formula of the polyatomic ion with the number of hydrogens it takes to neutralize that charge. Okay? Again, you do not put charges in the chemical formula for compounds, so we wouldn't put H plus SO3 - 2. The formula would just be H2SO3.